All right, here are the notes from the new unit that we're working on. So the I can statement is I can solve problems involving discounts, markups, and sales tax on merchandise. And the vocabulary for this unit, we've got a markup, which is the increase from what a store pays to the selling price. So stores need to make money, so they have to buy a product and then they mark it up so that they can make a profit. A profit is the money that they make. And in order to do that, they've got to mark their prices up. Sales tax is a percent added to a sale price. Like when you go to the Dollar Tree and you buy your dollar item and you take it up to the registers, you don't just pay the dollar, you pay $1, and then in North Carolina you pay 7% sales tax, which ends up being $1.07 on a dollar item. A discount is a decrease in the original price. That makes it cheaper, and you can get discounts by either coupons. Sometimes they have dollar off deals, or you can get a percentage off of the price. All of those things are discounts and they result in a cheaper price. And then a commission is a percent of a sale, and it's how some salespeople make their money. So for instance, if you go on a car lot and you buy a $10,000 car, the salesman may make 10% commission, which means that he gets a tenth or 10% of that $10,000, so he makes $1,000 if he sells you that car. If he sells you a more expensive car, like let's say he sells you a $20,000 car, and he makes still a 10% commission, then he would make on that sale $2,000. And then if the salesman doesn't sell you anything, so he makes $0, 10% commission on that would mean he makes $0. So when you go onto a car lot, that's why usually the salespeople will come out and greet you at the car, and they want to help you and they want to sell you a bigger and better car. And that's because the more money that they sell the car for or sell the vehicle for, the more money that they're putting in their pocket. And if you leave without buying anything, they don't make any money. So they're motivated to sell you and sell you things that are a little more expensive. So when we're figuring out sale price, original price, or the percent that we're paying or discounts, we can use this particular proportion to set up problems. So when you've got a discount of 30% off, up here we're not putting the amount of discount, we're putting the actual amount that we pay for the item. So if you're getting 30% off, to find the percent that you're paying, you take 100% of the item, that's the full price. You take away that 30% discount and you get 70%, and that's the percent that you're paying, and in this case that's the percent that we would be using in this proportion. When you talk about sales tax is added on to the end of the purchase. So to find the percent paid when you're talking about sales tax, you take 100% of your cost, you're adding that sales tax because you're paying more, so you end up paying 106%, and that's the percent that we would use on the top of our proportion. A markup is the same thing. So you would take the markup of 45%, and to find the percent that you're paying, you would take 100%. You would add the 45%, since we're marking it up, we're making it more expensive, and you'd be paying 145%. So that's just kind of going over the vocabulary and some of the new things. Then we have these 4 examples. So the first example talks about a graphing calculator. And the graphing calculator costs $90. The sales tax on that graphing calculator is 4.25%. And we want to know what the total cost of the calculator is. So when we're using the proportion, remember that we put the sale price or the selling price on top. The original price goes at the bottom. And that's going to equal the percent that you're paying, or the percent that was paid, over 100. So in this case, when we set up the proportion, sales tax is going to be added to the original cost. So we take 100%, which is the cost of that calculator, the $90 calculator, and we add to that 4.25%. So the percent that we end up paying for the calculator is 104.25%. And that's the percent that we're going to put in our proportion over the 100. So the 104.25 goes on top of the 100. Then we look at that graphing calculator, and the graphing calculator costs $90. And we're trying to figure out whether that's the original price or the price after we add the tax. And in this case, it's going to be the original price. And what we're trying to find is what we're going to end up paying for that when we pay the total cost of the calculator. And if you look, if the percent over here is over 100, then when we're looking for our total cost of the calculator, the part or the selling price is going to end up being larger than the original price because we're paying over 100%. Then we go ahead and cross multiply. So we've got 90 times 104.25, and that is 93,825. And then we're multiplying 100 times x, and that's 100x. And remember, when we cross multiply, those two things have to be equal if they're proportional. So we have 100 times some number that we don't know, and that's going to equal 93,825. So if we set up that proportion, then we're just going to divide by 100 to figure out what that number is. When you divide by 100 on this side, that just leaves me with the x that I'm looking for here. And then when I divide by 100 on this side, we're just moving that decimal. Oops. Sorry, moving that decimal back. So the decimal point here. So we've got $93, and then we've got 825 on the end. So we're looking to round that to cents. So when we round $93.82, when there's a 5 afterwards, we're rounding that 2 up to a 3. And we're rounding that because money only goes to 2 places after the decimal. So when we go pay for the calculator, we're going to pay $93.83. An alternate way to solve that problem is you're still going to add the 100% to the 4.25%, which is going to give us that 104.25%. You can change the percent to a decimal, and we do that by taking away that percent sign and then moving the decimal back 2 places. So that leaves us with a decimal of 1.0425, and that represents that 104.25%. and then we just multiply 90, which is the cost of the calculator, times 1.0425, and that's going to equal 93.825. And then again, money only goes 2 places after the decimal. We're using that 5 to round the 2, so it ends up being $93.83. And either method works. If you understand the decimal method, you can use that, and if you don't, just stick with the proportion like we have been using. Okay, example 2. Alan wants to buy a snowboard that has a regular price of $169, and this week the snowboard is on sale at a 35% discount. So what's the sale price of the snowboard? And again, we're using that sale price over original, and that equals the percent that we're paying over 100. So it's not the percent discount that goes there, it's the percent that we're paying. Discount is a percent of decrease, which means we're taking the 100%, we're subtracting that 35% discount, and that means that we're paying 65% for this snowboard. Set up our proportion with the 65% that we found here over 100. And then the regular price of the snowboard, the original price, is $169, and we're looking for the sale price. And in this case, since 65 is lower than 100, our sale price should be lower than $169. So we cross multiply 169 times 65, and that's 10,985, and then 100 times x is 100x. Those two things have to be equal, so when we cross multiply, we're looking for some number times 100, and that's going to give us that 10,985. So we set up our equation. We divide that by 100. 100 divided by 100 just leaves me with that 1x that I'm looking for. And 10,985 divided by 100 is $109.85, which is the price of the snowboard. Again, if you want to use decimals, so you find the percent paid, you're still subtracting that 100 minus the 35%, which is 65%. Change that to a decimal. So we've got 65 hundredths, and then we're just multiplying 169 times that 65 hundredths, and that again is going to give us that $109.85. Either method is going to give you the correct answer. For number 3, we've got a store that's paying $70 for a bicycle, and then the percent markup is 20%, and we want to know what we're selling that bike for. Remember that in order for them to make any kind of profit or make money, they have to mark up the price, because they've got to charge more than $70 for the bicycle if they're going to make any money. So we're adding 100% plus that 20% markup. That's the percent that we're paying. So the 120% goes above the 100. The $70 is the original price of the bike. And then we're looking for how much they're going to sell it for. And since 120 is bigger than that 100, our sale price should be bigger than $70 because they've got to make money. So 70 times 120 is 8,400, And then 100 times x is 100x. Those two things have to be equal. So we're looking for 100 times some number to give us 8,400. And if you don't know what that is, we're just dividing by 100. And that gives us the x is equal to 84. So they are marking the price up to $84 to sell it to you so that they make money. Again, you can use the decimals. You're still finding the percent paid by adding the 100 and the 20% that you're paying 120%. You're changing that to a decimal by taking off the percent sign. Oops. And then the decimals here, we're going to move it back 2 places. So it'll be 1.20. And then we're taking that $70, we're multiplying it by 1.20. And again, that gives us the $84 that they're going to charge for the bicycle. And then the last problem, it says, what is the original price of a phone that's on sale for $63 and had a 30% discount? So again, you've got to take 100%, which is the full cost of the phone. You're subtracting that 30% discount, and that's giving you a percent paid of 70%. So we're putting that number over the 100. In this problem, it says, what is the original price? Which means we don't know what that original price was. So this time the x is in the denominator, and it gives us the sale price of $63. So if the sale price is $63, when we get our answer, the original price should be more than that, because the sale price should be cheaper than the original price. So we cross multiply 63 times 100, that's 6,300. And then 70 times x is 70x. When you cross multiply, those things have to be equal in a proportion. So 6,300 has to equal 70 times some number. And if you don't know what that is, divide by 70 on both sides. 6,300 divided by 70 is going to give us 90. And 70 divided by 70 leaves you with just that one x. So our x is 90. $90 is the original price. That makes sense because it's more expensive than the $63. You can also use the decimal method this time, doing the same thing, finding the percent paid by subtracting 30 from 100 to get 70% that you're paying. Then we're changing that 70% to a decimal. So we're taking off the percent sign, moving it back 2 places. And this time, since I'm looking for that original price, I'm going to take the $63 and instead of multiplying it by 70 hundredths, I'm going to divide by 70 hundredths. And that's going to give me $90. Again, it doesn't matter which method you choose, as long as you are using the percent paid. That's really the only way that you can solve this particular problem. The other problems, you could have found the percent discount, markup, and tax and either added or subtracted. But in this particular case, you've got to use the percent paid. So that's, we're going to keep with the percent paid and just get used to using that.